Hi, good morning. This is Ms. Billerbeck. We're going to look at 7.2 interior and exterior angles of a triangle. So we want to find x, y, z. So x, y, and z. So we see we have two parallel lines here. So that gives us some information. So that gives us that 86 is a corresponding angle to 43 and y. It also is supplementary to x. So let's find x. So x equals 180 degrees minus 86 degrees, which gives us 94 degrees. Okay, then we know that 80 or y plus 43 degrees equals 86 degrees because these are corresponding angles. So 86 and y plus 43 is 86 degrees. We subtract the 43 degrees and we get y equals, and this ends up 43 degrees. Wow. So that's 43 degrees, or that's 43 degrees. And then we have alternate interior angles because this is a transversal here cutting across two parallel lines. So y and z is also, they're alternate interior angles, so they're congruent, 43 degrees. So that's really interesting. That's 43 degrees, that's 43 degrees, and this is an isosceles triangle because it has two sides that are the same. So if they have two sides the same, then their base angles, z and 43 degrees, are also the same. So that's one of the rules of isosceles triangles. All right, let's find x, y, and z. So we have x, y, and z. We're only given one angle here. Well, now we have two parallel lines going on here. So this and z, we know those two are corresponding angles because of the two parallel lines, this line and that line. So that and that are corresponding angles. So z equals 55 degrees. Okay, then we have isosceles triangle, which we just talked about. So if that's 55 degrees, that has to be 55 degrees because of the base angles. So y equals 55 degrees. Okay, so we know that there's 180 degrees in a triangle, so we can take 180 degrees minus 55 degrees minus 55 degrees, which is 110 degrees. So that gives us x equals 70 degrees. So there we go. We found them all. So let's look at a new theory, the exterior angle of a triangle. So the measure of an exterior angle of a triangle is the sum of the two opposite non-adjacent angles. So non-adjacent means next to. So what that means is this is my exterior angle. It's outside the triangle. Okay, these are my two non-adjacent angles. They're not next to this. Okay, so that means that my measure of CAT plus the measure of ACT equals the measure of ATS, otherwise known as Z plus Y. So Z plus Y equals X. So there we have it, the exterior angle theorem. So let's use the exterior angle theorem. So we want to find this measure here. So we have the measure of angle ACD equals, and we have two non-adjacent angles, 33 degrees plus 118 degrees. So that gives us 11, carry a 1, 5, 1. So the exterior angle is 151 degrees. Now we want to find the measure of DCF right here. Okay, so we have two parallel lines here. So we see that CBE, so we see measure of CBE is the exterior angle to these two non-adjacent angles. So we have 31 degrees plus 36 degrees. So when we add those together, we end up having 67 degrees. All right, so we also see that the measure of CBE, this angle and this angle, they're corresponding. So that means that this angle is congruent. So now we know the measure of DCF also equals 67 degrees because we have parallel lines, a transversal here, and corresponding angles. Okay. Now let's find the measure of CAD. So CAD. So I see I have two angles here. So I can learn what this angle is from that. So I have one exterior angle there. All right. So that angle, the measure of CDA equals 39 degrees plus 61 degrees equals, and that gives me 100 degrees. Okay, so I've got 100 degrees here. This one here, I know that, so I've got 100 degrees here, 52 here. So then I know if I add up these angles here to be 180 degrees, and I'm trying to find CAD, so then the measure of angle CAD equals 180 degrees minus 100 degrees minus 52 degrees. So the measure of angle CAD, since it's part of a very big triangle here, so 52, 100, I'm trying to find that one. So that gives me 80 degrees minus 52 degrees, which gives me 28 degrees, because 52 plus 28 is 80. Okay, so there we have it. Last example. So we want to find the measure of angle ADC. So we have ADC. All right, so we can do two exterior angles. So if we project that, well, let's see. All right, so yeah, let's do that. We'll project that we're going to cut this in half and make two different triangles. All right, so the full angle here is 55 degrees. And this one, we know that this is exterior angle 1 and exterior angle 2. Okay, so we look at this exterior angle, and let's call this interior 1 and interior 2, I2. Okay. Okay, so we have E2, angle 2 right here, equals this I1 plus 36 degrees. E1 equals I2, I guess I should have gotten those little subscripts the same, I2 plus 30 degrees. But we're trying to find the measure of angle ADC, which is E1 plus E2. Okay, we also know that I1 plus I2 equals 55 degrees. Okay, so now let's put this all together. We'll substitute this into here. So we have the measure of angle ADC equals, and we're going to put E1 is I2 plus 30 degrees in there. E2 is I1 plus 36 degrees. And then we end up getting the measure of angle ADC equals I1 plus I2 plus, and then 30 plus 36 is 66 degrees. We know I1, I2 is 55, so the measure of angle ADC equals 55 degrees plus 66 degrees, and that's going to be 11 carry 1, 121. So there we have it. So, and that was the last example, and I hope you have a wonderful day. Bye-bye.